Good afternoon, everyone. My name's Alex Bartfeld. I am the VP of Professional Services at Cloudera here in London, and I sit on the European management team. For those of you who don't know, Cloudera is a data management platform built on Apache Hadoop. And I'm here today to talk about the value of transforming into a data-driven business. And the journey I'm going to take is to start to talk about the changing nature of data. I'll then talk about how our customers and other organizations are using that changing nature of data to their advantage, and then finally talk about transforming your organization with a modern data platform. I think at a conference like this, these kinds of stats are probably not breaking news to anyone in the audience, but I think it's worth repeating just because they are quite staggering, that by 2020, the world will have, according to IDC, which is a research firm, 44 zettabytes of data. I admit I had to Google what a zettabyte is. It's a one with 21 zeros, or a million petabytes. So in context, a big bank would have maybe 10 petabytes of data, maybe a little bit more these days. And what's different about that data versus 10 or 20 years ago is that the majority of it is unstructured. We could probably have a semantic debate about what unstructured means, but I think it's fair to say it doesn't fit neatly into rows and columns. Most of it is generated by computers, by machines, and by sensors. So there are 7 billion people in the world. We're generating a lot of that data, but there are also, by 2020, an estimated 30 billion connected sensors. So every day, tens of millions of sensors are being manufactured and pushed out into the world, and those sensors are going to be sending data back to something, and I'll talk about what that something is in a few minutes. It's also noteworthy that at the moment, the vast majority of that data sits dormant. It's untouched. It's unusable, something in the order of 1% of it. It would be our ambition to get 25% of that to actually be usable and to drive business benefits. So why is all this important? Like, who cares? I think it's important because the penny dropped for me when I started at Cloudera and I saw how customers are using this data, but also even before then, something that the quant hedge funds figured out 10 years ago is that there's competitive advantage to be derived from having the fastest, smartest algorithm. I admit I'm a baseball fan. I don't know if any of you saw the movie Moneyball or read the book about a guy called Billy Beane. In baseball, every ball that was ever pitched and ever hit was recorded. So there is data in Major League Baseball going back over 100 years, or at least 108 years for those of you who know that the Cubs won the World Series a couple of days ago. And this guy, Billy Beane, he reduced the game of baseball down to a statistical model and used it to be phenomenally successful with a tiny fraction of the budget that was available to other teams. So that was a small data problem, but it was a data science problem, which he absolutely cracked. And I won't spoil the movie for those of you who haven't seen it. And so how are these new changes in data being leveraged? Well, data is extremely cheap, and I think the best way to describe that is to use this well-known quote, but I like it, and I'm going to read it verbatim, otherwise I'll get it wrong. Big data is what happened when the cost of keeping information became less than the cost of throwing it away, by a technology historian called George Dyson. It's not the vacuum cleaner guy, it's another Dyson. Big data is what happened when the cost of keeping information became less than the cost of throwing it away. In other words, the value that you can extract from your data exceeds the cost of storing it, both in hardware and software and people. And that was not historically the case. Why is it the case now? Computation has become a lot more affordable. Part of that is just purely down to Moore's law. So in 1965, Gordon Moore from Intel predicted that the number of transistors on a square inch of a microchip would double every 18 months, and it was reasonably accurate, actually, until recent years. Another driver towards these cost advantages is new technologies for distributed computing, such as Hadoop, which is Cloudera's product. And Hadoop resides on non-exotic hardware, so very industry standard type inexpensive hardware. It's also open source. And a lot of people think about open source purely in terms of the way that software is created from an R&D perspective, but there is a big commercial angle to it also. Any one of our customers can have the option of continuing to use Cloudera software and not pay us a penny. Fortunately, the vast majority of them don't do that. They continue to use our support services and our premium features, but every part of our product that touches their data or processes their data is open source, and they can use that. So what that means from a cost perspective, if you think about the old way of selling software, you would either pay the software vendor or you would lose the legal right to use that software, or in the case of software as a service providers, they would switch you off. And I'm not making any kind of ethical or moral judgment on that. That's a perfectly fine business model, but that's not the case with open source, and therefore that pushes pricing down, much to the chagrin of my sales colleagues in the room. I think there's a big angle from cloud computing also, that there is now a way that organizations can run transient workloads cost effectively. So if you have a monthly report, or I don't know, you're an accounting company and you need to run some kind of tax year-end reporting that would maybe only run for a few seconds or minutes, you don't have to reserve expensive hardware to do that anymore. You can spin it up in the cloud. We're seeing the pendulum swing, so the vast majority of our customers, as recently as 2 years ago, were running their Hadoop clusters on-premise, and that's now swinging quite rapidly towards cloud. The example I love to give about the economics of data is genomics. So 2001, the cost to sequence a genome was in the order of $100 million. Today, we're talking about less than $1,000. So that's not purely down to Moore's law. It's also about the way that you can achieve much higher rates of data throughput. So the nature of data is changing, and there are new competitive threats and opportunities that go along with that. So what's happening in the business world? Well, business is reacting, but arguably they're reacting in very traditional ways. So they're increasing their investment in infrastructure and storage capacity, and surprisingly less so in things like analytics, so making better, more predictive decision-making, information management, and then also the underlying business processes behind their data. No presentation, an event like this is complete without a quote from Albert. We cannot solve our problems with the same thinking we used when we created them. I know that a lot of Einstein quotes are actually weren't actually originated by Einstein, but I'm pretty sure this one is genuine. So business is going through a digital transformation. The nature of data is changing. And according to IDC, 89% of European CEOs have digital transformation on their agendas. So it's not like it's being ignored. I think that the need to use data to competitive advantage is front of mind. That's the good news. The bad news is that it's hard. Forgive the 1980s Pet Shop Boys motif here. I was going to blame my marketing team for putting this together, but actually 80s music is everybody's guilty pleasure, isn't it? Some people are looking at me like it really isn't. Anyway, back to the theme. So this is what we do in my team at Cloudera in professional services. We help make it easier. What's hard about it is, first of all, finding the relevant data and then being able to analyze it and interpret it, and even having a strategy in the first place. It's not all doom and gloom. Things are getting easier quickly. When I joined Cloudera 3 years ago, Cloudera culturally felt more like a computer science faculty at a university. There were a lot of brilliant computer scientists going around building cool software. But as we've commercialized and, let's say, grown up over the years, the product has become a lot easier to use. And if you look at tools these days like Cloudera Manager and Cloudera Director, even semi-technical people like I can spin up a cluster without making too much of a hash of it. Additionally, 3 years ago, you never saw Hadoop on a CV. So we're lucky that we attract a lot of really high-quality candidates. I maybe look at about 30 or 40 CVs a week. I'd say 3 years ago, maybe 5% of them had Hadoop on them. Now it's more like 90%. So ourselves and other providers out there have been training a lot of people, and the software's just become more prevalent, so people are getting more used to it. By the way, if you are a manager out there hiring people for Hadoop and for big data, I was thinking, should I give the secret recipe again? I think I figured out what the key is to hiring talented people in this space. So obviously you need to have foundational technical skills. That's like a hygiene factor. So we look for people who have a good understanding of development, of operating systems, of networking, etc. But actually more importantly than that, you're looking for people who feel passionate about learning the latest technology. Because if I was standing up here 2 years ago, I'd probably be talking about MapReduce. At Cloudera, we do about 15 projects a week just in Europe, and I can't remember the last time we touched MapReduce. So you need people who are going to be open and interested in learning the next thing that's coming down the pipeline. So businesses are looking at deriving various benefits from big data, better decisioning, more up-to-date decisioning based on more up-to-date data and larger data sets, and faster, and getting a higher return on investment on their business development activities. So we had an interesting use case with a bank a couple of years ago where they were selling loans to retail loans to customers. And the way they'd go about it is they had a telesales team who would just go down the customer list and call them up and say, do you want a loan? Based on the data which they already had, they were actually able to build a model for what is the profile of somebody who needs a loan. So statistically, what is the percentage that you need a loan today? And they would, that was data from the credit cards and from mortgages and from the bank accounts, et cetera. And they were able to get a 30x improvement on their conversion rate. So complete game changer for that industry. When you wrap all of this up, we see three major themes at a kind of board level. So first of all, driving customer insights, improving products and services, and thirdly, lowering business risk. And I'll give a couple of quick examples on each. So on driving customer insights, it's clear that the way that we shop has changed dramatically, and I'll do it myself. I needed to buy a new car seat for my kid last weekend. I went and looked at it in the shop. I thought, okay, I think I know which one I want, but I don't have any way to get it home, so I'm not going to buy it now. I went home. I looked at it online. I admit I did a bit of comparison shopping to see if I could get it cheaper somewhere else. I couldn't, and I bought it. And that's how people shop these days. It's through their mobile, it's through the web, and it's at the stores themselves. Marks & Spencer's, a long-standing customer of ours, they were able to figure out that problem. And in so doing, they were able to, first of all, get a better picture in real time of trends. So in different regions of the country, what merchandise would they be needing? They would also be able to predict which products were going to be most likely to be returned and why. And they also use clickstream data. So they had a mountain of clickstream data where they could see that people were going to their website, finding the piece of merchandise that they wanted, and then going and buying it cheaper through a partner. So clearly something was wrong with those business relationships, which they were able to address. In terms of delivering better products and services, so I think a lot of people have probably seen this. It went viral about 9 months ago, maybe a little bit longer actually. But I think it's important because if you think about what these businesses do, they've got no capital investment to speak of, or very, very little. Their assets are their data, and they've reinvented whole industries based off of that data by providing a platform to match supply and demand, or buyers and sellers of transportation, lodging, content, and consumer goods. And the other thing which is happening to rapidly change the way that products are brought to market is the Internet of Things. And when you go to conferences like this, it often feels like IoT is something quite abstract and still quite futuristic, but of course it isn't. If those of you who drive, I would bet that 100% of the people in this room use an app for navigation, like Waze or Google Maps or Apple Maps. And by doing so, you are arguably creating a connected car, right? You have a bidirectional data flow between your car and a Hadoop cluster. I also, there are lots of other examples. There's, probably a lot of you have an Apple Watch or a Fitbit or some kind of device making you a connected human. And the guy has probably come around to change your energy meter. So by 2020, I learned from the guy who did come around to change my energy meter, 80% of houses in the EU need to have a smart meter, which means that they can level out demand for energy, and it will encourage people through more tailored pricing to run their dishwasher later at night when there is a lot of supply and not that much demand. And the IoT use cases, of course, not just for consumers. The majority of them, 70%, will be from industry. And that's something which we've worked very closely with Intel on. And we do it ourselves. At Cloudera, our support team will gather data from our customers those who wish to. We have a phone a friend feature on every customer's cluster, and from doing so, they'll be able to spot patterns across our entire customer base. And most of the support cases which are logged for Cloudera are actually logged by Cloudera itself. Sorry, not most, but a large minority of them. Marker Studies, the biggest insurance company that you've probably never heard of. It's a real British success story. They're about a £1.5 billion company. They were able to do much better risk profiling using big data techniques. So if you think about how you buy car insurance, it's quite crude, really. I mean, they ask you where you live, what gender you are, how old you are, and your driving record. And that's pretty much it. But they were able to capture more information and come up with a much more sophisticated model and get much richer data, which meant a 50% improvement in customer retention, but also £5 million saved on fraud prevention. And for those of you who've been reading the papers this week, they did it in a completely non-intrusive, ethical way. There was a case of an insurance company trying to mine Facebook data and do some kind of processing on that to come up with a risk profile. So that wasn't it. And Cerner, again, back to healthcare, we've got quite a strong connection to healthcare. Actually, one of our founders uses big data to almost exclusively, his time is spent using big data techniques to do neuroscience research. And even Tom White, who is the guy who wrote the book on the definitive guide to Hadoop, so he's a colleague of ours here in the UK, he spends most of his time on life sciences. Cerner, it's a 20,000 person company. They use their big data to again, provide better products and services and to reduce readmission rates in hospitals. And finally, risk. So risk falls into three main categories. It's first of all cybersecurity. So, we all know that is an accelerating problem in the world, that there are individuals, corporate and obviously state actors out there who wish to steal things and do harm. Fraud, and then also compliance. We live in an increasingly regulated world over the last few years, and actually, if we look at the industries which are the most cutting edge across our customer base, it would be the more regulated industries, so financial services and insurance, telcos, and government itself. On cybersecurity, so a research firm called Ponemon calculated that it takes 46 days to identify and resolve a cyber attack, and most of that time is actually identifying it in the first place. And each one cost nearly $1 million. So that is a real problem. And of course, there are allegedly state-sponsored actors that are trying to influence elections in certain countries. In terms of fraud, so the credit card industry lends itself very well to big data. It wasn't MasterCard, it was another credit card company. And I find it really irritating when people on the stage do this, but I really can't say who it is. But there are really only three big ones, so you can narrow it down to two. But they implemented a big data Hadoop cluster, and within weeks were able to identify massive fraud, the largest instances of fraud that they've ever been able to see, purely because a lot of credit card fraud happens with small transactions over a very long period of time. And previously, they were only keeping 3 months of active transaction data. MasterCard are doing similar things. They were the first to build a PCI compliant cluster. So in their industry, there is this regulation called Payment Card Industry Compliance. And it was so successful that they actually built a spin-off, a consulting firm that helps other customers achieve PCI compliance. So those are the main three themes. What underpins all of them, of course, is a more modern data architecture. And while we all like to go and hear about the exciting use cases, actually, I think what drives a lot of organizations towards us and towards big data is just the fact that what they're doing right now is no longer fit for purpose for the changing nature of data. It's too expensive and it's not scalable. So BT, they took their 1,600 siloed databases and merged them all onto a single Hadoop cluster. And in so doing, they also increased their data velocity by 15x. And that was actually critically important. It wasn't just a nice to have. Their window for their ETL jobs was getting towards 24 hours. And once, of course, you exceed 24 hours, you're no longer looking at yesterday's data, and then you've got all sorts of business problems. They now use that to analyze network traffic and do all sorts of cool stuff for their business customers. And I've kind of done this on reverse, but I'm aware that a lot of people in the room probably don't know fundamentally what Hadoop is. And I'm not going to insult anyone's intelligence, but about maybe 6 or 8 months ago, I was invited to my 3-year-old son's nursery class to explain what I do for work, which is probably quite easy to do if you're a fireman or a doctor or something, but when you work for a open source big data company, it's a little bit trickier. Another Einstein quote, if you don't know, if you can't explain something simply, you don't know it well enough. So I'll tell you what I told them, and then you can tell me whether I know it well enough. So I started by holding up my Mac and saying, do you know what this is? And of course, every self-respecting 3-year-old knows what a computer is. It's a device that they use to watch Peppa Pig. And I said, so kids, imagine if you wanted to have every Peppa Pig that was ever made on this computer. And for the parents out there, you'll know that is a big data problem. And you wanted to count how many times Peppa jumped in a muddy puddle. This computer wouldn't be big enough, so we've got a problem. But back in 2006, long time ago, before any of you were born, there was a very nice man called Doug who came along, and he figured out how to connect lots of small computers. And this is where I got my Lego out, and I started clicking them together. And he was able to put all these computers together and stick them together and create a gigantic computer. And this is what a gigantic computer looks like. It's about the size of your school. But he still had a problem. He didn't know what to call his gigantic computer. But he was lucky because his son walked into the room holding his toy elephant, and his yellow elephant was called Hadoop. And so he thought that would be a great name for my gigantic computer, and that's what it became called. And by the way, for those pedants out there like me, Doug does actually call, he calls it Hadoop, not Hadoop, but that didn't even catch on inside Cloudera. So that's the story. And what that meant was that, first of all, again, it's open source, so it's extremely cost effective. And it's not a bit cheaper, it's in the order of 1 to 10% of the cost of traditional data warehouses. It's also extremely scalable. We've got customers who have licenses for well over 10,000 nodes. So, and we've tested it up to the to the multi-petabyte levels. And it's extremely flexible. We already talked about the fact that you can ingest any type of data into Hadoop. It is a schema-on-read system. But it's not just about the type of data you can ingest. It's about what you can do with it. So the world has moved on from just SQL. Of course, SQL remains an incredibly important part of every data analyst toolkit and isn't going anywhere anytime soon. And actually, Cloudera has invested a lot in real-time SQL through a tool called Impala. But things have moved on from just SQL. So first of all, batch processing, obviously, Hive lends itself extremely well to batch processing, streaming through Spark, and then going back to the original roots of Hadoop, which actually came out of 2 white papers from Google, you can perform search on your data also. Finally, just with a tip. So it's very hard to do a big bang approach to big data, to forklift probably decades of data warehousing onto a Hadoop cluster. Our recommendation is to start small. First of all, identify what data sets are available, and Hadoop gives you the ability to actually ingest it into a raw layer. And then go to your business and say, what are the questions that you would like to ask that were not previously possible? I think that's a reasonable question to ask any business leader. And then iterate. Normally what happens, in my experience in professional services, is you put the infrastructure in first. It always goes well. We always get a production cluster up and going with all the lights green. And then there's suddenly a big buzz of excitement, and you create a lot of use cases start flying your way from different parts of the organization. So you need to have a very strong governance model in place to figure out which of those use cases are going to give you the most benefit and which are the quickest and easiest to deploy. And I would also say that go for a quick win use case up front. So something that is either going to derive a big business benefit that wasn't previously possible, or something that just looks cool. We've done some customer 360s that stream different data into consumer iPhone apps. Those kinds of things go down really well. I'm out of time. If you would like to talk any further about any of this, then please, I'll be at the Cloudera stand for the rest of the afternoon. Please come on by. Thank you very much.